As amazing as the nature that we can see is, there's a whole side of it that we can't. You know the structure of atoms, they contain protons and neutrons and electrons, but today we're going to talk about what's inside protons and neutrons, particles called quarks. And we're going to discuss that every particle has an opposite particle, an anti-particle partner, negative protons, positive electrons. So welcome to Quarks and Antimatter. I'm Howard, and this is how it works. Inside protons and neutrons are particles called quarks. There are 6 different flavours of quark: up, down, charm, strange, top and bottom. Yeah, their names are a bit weird. They're organised in 3 generations. The first generation is up and down, the second generation is charm and strange, and the third generation is top and bottom. Typically, at age 16 or 17 in the UK, you study the up, down and strange quarks as part of the A-level physics course. There are 3 quarks in a proton and there are 3 quarks in a neutron. The 3 quarks you find in a proton are 2 up quarks and 1 down quark, whereas in a neutron you find 2 down quarks and 1 up quark. This means that a proton and a neutron are only 1 quark different. As the down quark is slightly heavier than the up quark, the neutron is slightly heavier than the proton, but you have to measure to 5 dP to see that difference. The charges of the quarks are also a little bit weird. We're told that the fundamental charge is that of the electron, 1.6 times 10 to the minus 19 coulombs. Because one proton has 1.6 times 10 to the minus 19 coulombs, but there are 3 quarks in a proton, they must have fractions of that charge. The up quark has plus 2/3 the elementary charge, and the down quark has minus 1/3. So in a proton, you have 2 up quarks, that's 2 lots of plus 2/3 relative. Add those together and you get 4/3 relative charge. Subtract the 1/3 for the down quark and you're left with 3/3 or 1 relative charge, as you'd expect for a proton. For a neutron, you have 2 down quarks and 1 up quark. Well, 1 up quark has plus 2/3 relative charge. You're then going to subtract 2 lots of 1/3 for the 2 down quarks and you're left with 0, as you'd expect for a neutron. In each generation of quarks, you have 1 quark with plus 2/3 relative and 1 quark with minus 1/3 relative. The up, charm and top quarks all have plus 2/3 relative charge, while the down, strange and bottom quarks all have minus 1/3 relative charge. Any particle that's made out of quarks is called a hadron, while any particle not made of quarks, like an electron for example, is called a lepton. Leptons, as far as we know, are fundamental. You can't cut them in smaller pieces. Hadrons, however, are made of quarks, but there are many different kinds of hadron, based on the number of quarks and the arrangement of them. The 2 most commonly studied hadrons are baryons and mesons. Baryons have 3 quarks in them, like protons and neutrons, and mesons have 1 quark and 1 antiquark, while quarks are an example of matter particles. There are also antiquarks, which are members of the antimatter family of particles. Every single particle has an antiparticle partner. Antiparticles, or antimatter, has the same mass as its normal matter counterparts, but everything else about them is the opposite. So, as we've said, the up quark has plus 2/3 relative charge. The anti-up quark has minus 2/3 relative charge, but the same mass as the up quark. The anti-strange quark, for example, has plus 1/3 relative charge, but the same mass as a strange quark. There are other properties that we give to particles other than their charge. For example, the strange quark has a property called strangeness. Strangeness in hadrons basically tells us whether or not there's a strange quark in it, but as the name suggests, strangeness is strange. The strange quark has minus 1 strangeness, whereas the anti-strange quark has plus 1 strangeness. Every other quark has 0 strangeness. So if a hadron has minus 1 strangeness, it's probably going to have a strange quark in it. As 3 quarks combine to make a baryon, you can also have 3 antiquarks combining to make an anti-baryon. For example, 2 anti-up quarks and 1 anti-down quark combine to make the opposite of a proton, an antiproton. A particle with the same mass as a proton, but minus 1 relative charge. An antineutron is made from 1 anti-up quark and 2 anti-down quarks. It also has 0 charge. You might ask, how is an antineutron different from a neutron? If it still has 0 charge and the same mass as a neutron, then what's the difference? Another property of particles is called Baryon number. The rules are easy. If it's a baryon, it has 1. If it's not a baryon, it has 0. And if it's an anti-baryon, it has -1. The antineutron is an anti-baryon. It's made from 3 antiquarks. And therefore, although it has the same mass as a neutron and the same charge as a neutron because it's neutral, it has a -1 baryon number. Back to the other kind of hadrons, mesons. Mesons are not made from 3 quarks, nor are they made from 3 antiquarks. Instead, they're made from 1 quark and 1 antiquark. There's no such thing as meson number. If a meson is made from 1 quark and 1 antiquark, and you wanted to somehow make an anti-meson, you change the quark into an antiquark and the antiquark into a quark, and you'd end up with another meson. So there's no such thing as anti-mesons, and therefore meson number isn't really useful to us. Leptons also have antiparticles. The electron is a lepton, but the anti-version of the electron has got its own name. You may have heard it before. A positive electron is called a positron. The positron is the antiparticle version of the electron. It's extremely light, its mass is the same as the electron at 9.11 times 10 to the minus 31 kilograms, but it has a positive charge, relative +1. So, to summarise so far, we have hadrons and leptons. Hadrons are made from quarks, leptons aren't. An example of a lepton is an electron. An example of a hadron is a proton or a neutron. Hadrons are split into baryons and mesons. Baryons are made from 3 quarks, antibaryons are made from 3 antiquarks, and mesons are made from 1 quark and 1 antiquark. There are 6 different quark flavours: up, down, charm, strange, top, and bottom. Please leave a like and subscribe if you want to see more informal physics content like this, and hit the notification bell if you want to be notified of upcoming videos about more in-depth areas of particle physics. Stay tuned for videos on things like conservation of quantum numbers and pair production and annihilation in the near future. I'm Howard, and that's how it works.